Hello everyone. So welcome to this course. This is Advanced AI 101. So we'll start with the foundations of AI. So as to not get you bored, we'll continue with some real life examples to teach on how to start with AI for the ones who are just moderate and the ones who are first time touching AI. I hope no one gets bored. So that will be my motive. Let's start. So, AI is not just smart chatbots. Some people think that AI is merely a ChatGPT, but it's not. ChatGPT is just one thing. So, AI rests upon maths, logic, data. Data is one of the finest thing for AI, and largely computing, for which the greatest example can be Nvidia. As of now, the one of the finest, one of the top company of in this world, valued at $4.4 trillion. That is huge. So computing is one of the very toughest thing, one of the challenging thing, and yes, one of the um, thing that is full of money. So let's go beyond that. Let's dive into what AI is and what do we need to know if we have to gain a good foundations in AI. First off, linear algebra. So linear algebra is one of the most required field, which includes vector, matrices, tensors. Like one of the finest importance in AI is matrix multiplication, used to multiply two different images to form a vector, and so that it can be used in computer vision. Similarly, the another most important topic can be probability and stats. That's because probability, considering the modeling and uncertainty, Bayesian reasoning and Markov model, it tells us what event has what probability. And stats is important to model your reasoning, to show mean variance distributions, to show data to your CEO, and to actually refactor your reasonings to show what understanding you have, what response you have, and why is that moving this shelf to the right hand side will increase customer churn or sales. So yes, the data science part. Lastly, a bit of calculus. Now calculus is also important for AI since the fact that gradient descent and AI, the backpropagation and deep learning concepts are based on calculus. Logic, and which can also be said as discrete maths, is also really an important topic for AI. So this has all been the maths part for now, but we haven't dived yet into the computer science part, which includes data structures like linked list searching and algorithms. Many important algorithms like DFS, BFS, and A star search and dynamic programming has been used. Complexity of these algorithms is also one thing. So without further ado, let's start off with AI. One important thing in AI is federated learning. So what is federated learning? Federated learning is basically, let's assume we all have smartphones. Now in that smartphone, the keyboard we use, that Google keyboard, we see that in that keyboard, often that the words we usually type, like my name is Sohaib. So it's usual that I type Sohaib. Now, whenever I'm typing, there are word suggestion coming up, Sohaib. But at the same time, in your phone, you don't know me, so that word suggestion doesn't come up to you. So the fact is that this is called federated learning. The model is learning new data and it's showing up to my presence, but at the same time it's not replicating on your device. So the fact is, a model is learning, but it's not transferring learning to the Google's data center. It's not transferring. So what happens is that data stays local. That the word that has been learned stays locally, and only model moves. To this main server. So this is the way how federated learning works. So what's the use case right here? The use case is not just this Google keyboards. Many fintech companies, banks, they work on the compliance systems like GDPR and HIPAA. These HIPAA compliance and GDPR is basically that your data stays locally, the data stays in the country where the customer resides. For suppose there is ABL Bank, Allied Bank Limited in Pakistan. So that bank agrees on the fact that its customers' data won't be moved outside of Pakistan. So the Pakistan has strict regulations that its data, its KYC of the customers will not be moved outside of the Pakistan. So what does that mean? It means that ABL cannot use cloud for AWS, since AWS doesn't have data centers. So what it does is the data stays local. In the model can move, the data stays locally in the nationwide in Pakistan. So the data center has to be local and inside the nation. So these are the few things. I think let's discuss agent function. So what agent is? Agent is a guy who actually performs some task. So let me go to a bit of introduction for the agents. So what do you think an AI agent is? So well, for now, our learning is that if we go to ChatGPT and ask what the cheapest flight available for tomorrow from New York to London, it would say that for tomorrow, I literally don't know, because my knowledge is still till December 24. It's unaware of what is tomorrow, what's the current data, what's the rate tomorrow, what's the flight rate tomorrow. It's not aware of that. But if we go and attach an API, if we go and ask the same question but attach an Expedia API, which is a travel API, so by the help of this, it can answer me that yes, 1200 for economy and 3400 for business class is the cheapest I can get. So, but if I ask the same question, book me the cheapest flight available tomorrow. Before this, I was just asking what's the cheapest flight. It was giving a simple answer, but now I have changed my question. I've been asking, book me the cheapest flight available tomorrow. I'm giving the same API. Now, what it does is that it searches all the flights available from New York to London. It selects the cheapest through an algorithm maybe, and finally does the step. Thus, what the human has to do, actually book the flight using the customer's credential. Once that is done, it states the flight has been booked for 1200 and the confirmation is sent to your email. So this is somewhat really fascinating. So what it does is you give it some input, it senses using the web scraping, it checks, searches the cheapest flights, and it does the action using the actuator. So this is what AI agent is. It takes input, thinks and acts using the tools. For now, the tool was the API I provided. and the action was to book the flight. The one thing very important to remember is that it is autonomous in all fashion. So autonomous means it's working only and only for you. It's no one else is involved. There's no third party in this. It's only serving you and your prompt. So here is what prompt engineering comes in. Let us get back to the PS framework. So we've often been taught PES framework. This is quite used for AI agents. So the P stands for performance, E stands for environment, A stands for actuators, and S stands for sensors. So let me give a bit detail on this. So the performance, that the AI agent we just mentioned, does it actually book the lowest flight? Is it a true positive? So all these metrics are considered for performance. If it's actually working according to the need, so that comes inside the performance metric, and that we are supposed to set that. Environment, for this environment was an API. It was the whole available internet, and it was also us, since we were interacting with it through a prompt. Actuators were again by using an arm, maybe the touch was working itself, so maybe it's a playwright function that actually uses a DOM element and clicks the button itself. And the sensor would obviously be the screen again, or maybe the DOM elements, since all the ticket details and the prices are received in the DOM of the web page. So yes, it can be DOM as well, it can be the screen as well. So we can build on an example for now. Let's go for a good example. So a self-driving car. For a self-driving car, let's assume so for this, I think a self-driving car, the performance would be that the customer or the passenger is safe and is in comfort. Maybe the comfort level is the performance metric. If the passenger really feels comfortable in the car, I think performance metrics is achievable. E, the environment can be the roads, the pedestrians, the obstacles. Can the self-driving car actually see the obstacles? That will be our environment, because when there's a car driving on itself, there are several obstacles like roads, people like us, pedestrians, traffic signals, weather. So all these come into the account. For A, actuators, it can be the steering of the car, the brakes, which people don't apply usually. So steering, brakes, accelerator, all these. And for sensors, we can have a camera. Since it's not a human being, use a camera or radar. So a radar can also be a good thing to actually calculate the location with the GPS, also the GPS, right? And a speedometer. Actually, it's not driving too fast, right? We have to monitor that as well. So yes, I think this way we have covered this PAS framework. So next thing that we should be discussing is the type of environments. Now, if this is actually a bit of open-ended thing, and I think everybody has the brain to think of it themselves. So firstly, we should be knowing the dimensions of these. for the dimensions, I believe there are things like that it is partially observable or observable only, right? It can be fully observable or a partially observable thing. Partially observable actually thinks that, like for a self-driving car, the partially observable thing that is that beyond a wall, if it cannot see, right? You understand that a car has a camera, and a camera can see a wall in front of that, but beyond the wall, the camera cannot see. So that is the reason it is partially observable. But for a board game, maybe a board game, it is fully observable. Like we are playing a chess game, so I can see the whole scenario on the board, and my opponent can also see. So this was a good example. Then the second type, dimension of the environment is single agent versus multi-agent. This is merely very simple. The fact that whether we have deployed a single operating agent or is multiple agent trying to solve the same game. Like for example, if we are devising a soccer game, for soccer we can deploy multiple agents that are playing for us and actually making us win against our human like opponent on a FIFA game. So yes, this way we can have deploy multiple agent. Then the most important part, the dimension, is deterministic versus stochastic. Now this is really important. Deterministic is that the next state is fully determined by the current action, current state plus the action. If we know that if we go forward, our location will be +1. If we move to the next block, we'll be adding a block to our GPS. So this way we know and it's clearly defined. But as stochastic, we don't know, since the action can have uncertain effects. Like we don't know that if we don't know what the weather will be tomorrow, what the weather could be. We know a percentage that yes, it might be sunny tomorrow, but we are not 100% sure. We are never 100% sure that it would be sunny or it would be rainy. So this is one stochastic behavior of the nature, I think. So this was the example for this. And the fourth thing is episodic versus sequential. So episodic is that each action actually is independent. For instance, in episodic, like you can suppose image classification, each image is separate and there's no past dependency. But sequential is that if we make a bad move, it will obviously affect the future decisions. So like in the chess game, we know that if we make a bad move right now, moving a horse to the left, and in future getting off, we'll be risking our queen. So every action is dependent, but in episodic, it's not. So let's move on. Static versus dynamic. So in static, the example can be the environment doesn't change, while in dynamic the environment can change as well. Like in dynamic, you can assume for self-driving cars the environment contains pedestrians and pedestrians are moving constantly. You cannot assume when the pedestrian will move to the next step and at what speed he's walking. So but in static, the environment doesn't change. For this can be a crossword puzzle or maybe monopoly game or sequence game. So Yes, this is a good example. So with our last dimension is discrete versus continuous. So in discrete, we have finite states. I think I don't have the need to explain states, because states are dependent on the actions. States are basically the next step you take, next step you are leaded to. So in the continuous state, you have a wide range of values like speed, steering, angle, positions, which angle you can take. But discrete is always a finite things which can be countable. So yes, this is it, and I think I've covered the major fundamentals of AI, advanced AI. And moving forward to the next chapter, and we'll be discussing very interesting things in future.